Learn Nim in 5 minutes. There we go. Okay. So I don't think at this point I'll be writing any code. I just need to continue going through documentation and basically see what is happening. So learn Nim, 5 minutes apparently. Nim, formerly Nimrod, is a statically typed imperative programming language that gives the programmer power without compromises on runtime efficiency. Nim is efficient, expressive, and elegant. Okay, so we start with the most useful thing, which is a single line comment. Start with a hash, just like in Python, I believe. So multi-line comment can be started with hash and square bracket, and close with that. And multi-line comments can be nested. Okay, I like that too, because sometimes, let's say you had a comment, a block of code that you had used a multi-line comment block in there, you can surround it, and this way you won't have issues where suddenly this here ended your comment and you have some mess. I like that. Discard. Interesting. And then we have 3 quotes, so I guess this is a multi-line. Yeah, it can also work as a multi-line comment or for unparsable broken code. I guess because it's discarded. So I guess they're showing us 2 features here. First one is discard, as you can discard something. And a feature where you can write multi-line strings. I don't think it's just a comment, it's a string. But in case it's discarded, so it's a comment. Okay. So I guess the compiler is smart enough to just ignore that. Okay. Declare and assign variables with or without type annotations. Okay, so we declare a variable with var. We declare a letter, so it's a character. And yes, single quotes for a character. And then we have language, which is ampersand im. So I guess, these are 2 strings because they have double quotes and they're concatenated into a single nim. Okay. And length is an integer. And looks like we have a built-in function for just getting a length of something. So we can get a length of a string, which here I presume will return 3. Then we have float that we can specify, and we don't have to assign any values. I presume it will get assigned default value, which will be 0 in here. And then we have truth, which is boolean. Cool. Simple. Okay. Let. Use let to declare and bind variables once. Oh, okay. So here legs is immutable because we declared this as let and we gave it a value. And after that, you can change it no more. Okay. And here underscores are ignored, so you can just easily make large numbers readable. And this, I presume, will be float. Okay, so I like that distinction between let and var. Var is something mutable that you can change, I presume. Well, let is something that you can assign once, and that's it. And then you have constant. So constants are computed at compile time. This provides performance and is useful in compile time expressions. Okay, so constants are only at compile time. And again, the type is basically the compiler figures out the type on its own. Also for constants, that's awesome. So we basically have constants as values that you assign once, but then the value needs to be needed at compilation time, so before your code runs. Then we have let, which seems like is also assigned once, but you can probably run some code during runtime here. So this will be assigned during runtime. And, let's say you create an object and it needs to assign that. It takes it from the configuration file. And after that, the rest of your code won't be able to reassign it. Therefore, it will stay the same. So that's really nice. It makes it clear that, hey, this shouldn't change. Var is immutable, so it can change. Cool, I like it. When compile bad code. When is a compile time? If. Okay. This error will never be compiled. Constant values must be known at compile time. So I see. So this is like in C#, you can have like pragma if statement where you can decide if code will be compiled or not. So this is similar. This will be basically calculated only if compiled by the code is true. So here we have a constant that's being defined as false. And because of the constant, it was evaluated during compilation time. And therefore, this code just won't even get compiled. So there will be no errors because you won't be able to, because this wouldn't work, because you can't, legs is, one-time assignment, so you can't reassign it. And we're trying to define a constant input by using readline, and readline is basically waiting for user input. So this is not something that's known during compile time either. Okay, I like that. Simple. And discard 1 is larger than 2. Compiler will complain if the result of an expression is unused. Discard bypasses. Okay, so basically if we have 1 larger than 2, that little thing returns a value, true or false. In this case, it'll be false. But this value isn't used anywhere, isn't assigned anywhere, so the compiler will be like, something's not right here, and it can discard it. Okay, that's straightforward. I like it so far. What else do we have? Data structures. We have tuples. We can declare a variable child. We can explicitly say that it's a tuple and give it 2 named values with types. Tuples have both field names. Okay. And order. Okay. So yeah, that makes sense. Tuples are ordered because if you would use tuples in C# or in JavaScript, I think JavaScript has tuples. Maybe TypeScript has. I don't remember. Go has tuples. Then you would address them. You could address them by, saying child and then the square brackets and 0, which is index of the property inside. But here you can get them names. That's interesting. So we have child. We are overriding it. Name and age. So you can assign all at once with the literal. Okay, so basically when you want to override tuple, you can assign values. You just need to make sure that it's in normal parentheses. It's just the way how you would create tuples in other languages. Or you can just assign specific values to them. And you can use dot notation. So that's awesome. That's like at this point, this acts like a little object. Because you can refer to things by name. I like it. Then we have sequences. So we can make a sequence drinks. It's a sequence of strings. And yes, then for sequence. So we have that @ symbol. And then in square brackets. This is the sequence literal. Okay. So we assign drinks to here. We water, juice, and chocolate. Okay, 3 strings. And then we can add something to the sequence. Okay, so sequences are basically like mutable lists that can grow in this case. So it's not like an array where you would specify, okay, there are 3 elements and you can't add anything, you can just assign within those 3 elements. So I like that. We have sequences, we can iterate over them. Oh no, wait, that's not if milk is inside drinks. Okay, so you can check for contains. That's cool. And if we have milk, we say we have milk and here we calculate the, oh, interesting. Somewhere here, we're using length before, while here, like a overall global function, while here we're saying drinks dot length. I wonder if they're interchangeable and you can do both. Interesting. So, and other drinks. So I guess echo can take just different, however many arguments there are, one by one, and we'll concatenate them on its own. We don't have to use ampersands here. Okay, and it automatically converts integers to strings. All right, and then we say my drink, and we get a specific index, number 2. So it'll be 0, 1, 2. So he wants chocolate. Okay, my drink is chocolate. What else? Defining types. Defining your own types puts the compiler to work for you. It's what makes static typing powerful and useful. So we can declare type, and I guess you can define several types at once. So first we define type name, which is a string. So a type alias. Okay, type alias gives you a new type that is interchangeable with the old type, but is more descriptive. Okay, so basically instead of saying that something is of type string or of type int, we can now say that it's of type name and age, and everything will still work the same. So if you pass it to a function that expects, for example, a string, and you will give it something of that type name, it'll still work because underneath is a string. Okay, makes sense. Person, and we define it as a tuple. So here we define a shape. So basically whenever we say it's of a type person, it will basically expect a tuple. Okay, you can also define tuple. Instead of those square brackets, you can just go top down. Just make sure you indent. Okay, I like it. Simple, easy to read. And we create variable, and it's a person. Yes, we saw that assignment already. New age, integer is 18. We better to use age than int. Yeah, you could, I guess, change it to and. So I'm understanding this is written as if you could run it yourself and read it in there. So let's try that. Can I go back? Documentation, official name playground. There we go. So if I'll grab all this code, there's no copy. Okay, and we paste it here. So let's get back to things. Let's just try to run it and see what happens. Okay, we have milk and 3 other drinks, really good books lately, and unhandled exception. Okay, so we'll get there. So we basically, when we executed it, we had all those variables, we went through that. This didn't trigger any errors. If I'll change it back then to true and run it now, it should probably legs cannot be assigned to and something. So yes, this instantly here tried to execute and complains that we can't assign anything to legs. All right, if I would comment it out by putting this in front and run it, it would probably complain about that because we cannot evaluate at compile time. Perfect. Okay, that stays. We just make it false, and we can run it again. And all that should be discarded. Okay, so through that data structures we went through this, and we echo that we have milk and 3 other drinks. That I was here. That's good. And we could probably add something like echo my drink, and we could say my drink is and comma and run it, and that should say that my drink is chocolate because chocolate was 2, right? Yes, my drink is chocolate. So we know for sure that sequences are indexed from 0. Cool. We had our tuples, where we're defining them. We went through that. Let's just get back to our types. And we said that we have this and a new age. It's integer 18. So it would be better to use age. So if we would use age, it should still work normally. Oh wait, look, here we have an example. So we declared new age as integer with a value of 18. Here we're basically taking our person. Our person is defined that it's expecting age, and age is an integer, alias for an integer. That means that, also works because and an age are synonyms. Yeah, they're basically, the same thing. Okay, I like it. Then we define type cache. It's a distinct int. Distinct makes a new type incompatible with its base type. Oh, I see. So even though the cache is integer and description is string, you wouldn't be able to assign normal integers. So we have var money cache is 100.cache. So .cache converts the integer into our type. I see. The same thing with string. We have a string, but we still need to convert it to that description type. Oh, that is really nice, because it's often that you want to, let's say you're working on some functionality that you have various number of units. let's say that you want to have units like pounds and kilograms and yeah, let's go feet and inches. I mean feet and inches and centimeters, right? So you can represent all of them as integer or maybe floats if you want. But when you make them distinct, so let's say I would say that there's something like a foot, and let's do inch, and that's distinct float. And then we decide the centimeter is distinct float. Okay, we have those two units. Both are describing length. So you can say that, let's say, what do we have? New variable. Okay, new variable, and let's say that would be the monitor diagonal. And we can say that it's in inches. And then we can say that it's, let's say, I don't know, 30. If I would say it's 30. This should complain because we're trying to put integer into float. So let's see that. Error, undeclared undefined is no distinct. Run again. So now we have small error. Those errors are small. Error, type mismatch. Got integer literal, which is 30 for 30, but expected inch equals distinct float. So if we'll make it 0.0, which will be a float, right? We run it, it should complain that it's a float. Yeah, float 64. Oh, interesting. So it defaults to float 64. But expected this. So I would need to say .inch. And we run it, and it's happy. No problem. Okay. But then, let's say we have another variable, and we define it as, what could it be? Phone diagonal. Okay. And we say that it's centimeter. And this way we would need to define that, hey, this is whatever that will be 16 centimeter. So these, I don't know if that's gonna work. It worked. Even though we have an integer, we were able to, and this is defined as float, so we're able to change into that float. Okay, that's fine. But that means that later I can't make it, for example, where phone diagonal is, let's say, a phone grew to the size of a monitor, which is monitor diagonal. You can't say that, so that therefore you shouldn't be able to mix those two. Yeah, mismatch of inches and centimeters. So you won't have, you know, a stupid mistake that, oh wait, this was supposed to be centimeters instead of inches, because you need to explicitly say, I presume .centimeter. If I would say that, I presume that this will allow inch to just turn into centimeter, and now it's fine. Even though, you know, here you explicitly need to convert one into the other, that means that you need to be aware that you actually made a conversion. And this is something that can prevent some really nice, pretty nasty problems. Okay, I like that. So let's just ignore that and see what's later. So yes, we can say money is cash, description is description, and compile bad code. So we had that age, which was supposed to be age, even though it's an integer behind it. We can't assign money to it because money is, I mean, cash is distinct. Yes. And the same thing with strings, because description is distinct of string, therefore they won't work. Awesome. More types and data structures. Enumerations allow a type to have one of a limited number of values. Okay, so we have color, and that's an enum of C red, C blue, and C green. Okay, and then we have another one, which is direction, and we can just, you know, instead of make them one line, we can just present them this way, which I sometimes would prefer, I guess. Okay, it's interesting. So the color, they all start with C, while direction they all start with D. Interesting. And then we create a variable, orient, d north. Oh, okay, so you don't even need to say that it's a direction dot north, just say d north. That's probably why they prefix everything with the d like direction or c like color. Okay. Well, pixel is c dot green. Okay, cool. So that's again the compiler inferred that hey, you probably mean that. I like it. And enums are usually an ordinal type. Ordinal sounds like something that will be ordered, as in counted. So therefore, you can compare the north to the east. So I guess this is 0, 1, 2. So this will be false. If I would do echo the north larger than the east, let's see if we're gonna get result, and it should be false. Yes, the north larger than the east, false. Perfect. Subranges specify a limited valid range. So we have type, difaces, it's a range from 1 to 20. Only an int from 1 to 20 is a valid value. Oh, that's really nice. That is really nice. So you won't be able to pass in like too large or too small value. I like that. And my role is difaces 13. If we would try to give it 23, then it will complain that, wait, you can't assign 23 to the range of 1 to 20. I like that. Okay, so we had sequences. Now we can look at arrays. So arrays, type, roll counter is an array. Arrays are fixed length and indexed by an ordinal type. Oh, I see. So indexes are not just integer, like pretty much everywhere else where whatever other language are used. Here we can actually specify that, hey, so we have already an array of from 1 to 20, and that's it. You can put direction, which was an enum of 4 values. That is interesting. Or again, you can say truths from 42 to 44. So I guess we'll have 3 elements. So far, those values were inclusive. Everywhere we had this thing here. So counter is a roll counter. So, okay, we have an array of those direction names. Possible is truths. Okay, so we basically create a variables from that. Possible, which is truths. We have 3 elements, so we can say false, false, false. So we'll be created with that. Okay, that means that we basically, the index 42 is false, index 43 is false, and index 44 is false. And all the other indexes don't exist. That is a very interesting approach to arrays. Possible 42 is true. So yeah, we can override it. What happens if I'll try to echo it? And we just do this. I will display it. Oh, just say true, false, false. Perfect. And if we would try to do possible index 0, it should just complain that it's not possible because it's not between 42 and 44. Yes, index 0, not in 42, 44. I like it. Prints the whole range for you. What if I'll do directions 0 or like directions 100 because there were only a few directions? How will that print the values? Type mismatch. Okay, one has their name and one is integer. I like it. Okay, works, makes sense. I like it. Direction, and here we can say the north, it's that, while the west is that. Okay, so we can assign that. That's a nice name because sometimes you need to create those small types, like let's say you're working on a game and you need to store just some direction, a single, like an array of possible directions or something, or other possible values. And let's say you have a little tile, and usually in games, and from that tile you can go in each direction and diagonals, so you have 8 possible directions to go, and you could specify what is the cost to go in each direction. So you basically can make an array of your directions with a value of your cost, which is, I don't know, integer or something. And this way it'll be made sure that you don't specify it by 1, 2, or 3. You need to specify by that specific enum, and the compiler will stop you from doing something wrong, from introducing a bug or something. That's awesome. So what's next? My roll is 13. Counter my roll increased by 1 and increased by 1. So where was the counter? Okay, counter is of that. And we have my roll, which is 13. So we can take the index of 13 and increase it. So die faces was just a range of integers. So it's fine to get that number 13, the index 13, and just increase it twice. Okay. So basically added to our counter of rolls that, hey, roll 13 and 13 again. Okay. Somebody has bad luck here. Okay, and another array. And this looks like you just create an array of just 3 strings. Default index starts at 0. Okay, looks like we went through the arrays and we have just a little bit more left. More data structures are available, including tables. So we had tuples, we had sequences. Sequences can grow and always start at 0 and are indexed with integer. Then we have arrays, which can have custom index, and I presume they have to have fixed size because we haven't had an example of adding new values to an array. And then tables. So tables, we saw one at some point, I think. So I presume tables are multi-dimensional arrays. Interesting. Sets, okay, I like that. So we can just make everything unique. Lists. Are lists different from sequences? Queues and bit trees and all that stuff. Okay, so we basically have plenty more that's already made. Cool. We can go to IO and control flow. Case read line. So echo, reading good books lately, and it's basically waiting. Okay, so it's waiting for user to input something, and we basically do a switch case on that. If it's no or no, so again we can put 2 variants here. Go to echo library, and if yes, again both cases, carry on then. And else, that's great, I assume. So if we put something else, then yes or no. Okay, that makes sense. And when we run it, I guess here, this little thing doesn't really work because we can't put stuff in. But if we would just say no and run, will the compiler be angry about that we're doing a case on? Okay, I'm thinking of a go to your local library. Okay, so yep, that works. Cool. Then we have while, if, continue, break. So that's interesting. We can import somewhere in the middle of the file too. We don't have to import, everything at the top. I like it. So we import string utilities. I'm thinking of a number between 42 and 43. Guess which? So we of course all know which number. It's 42. So we assign a number, we can't reassign it. We create 2 variables. Raw guess, which is a string, and integer string. Okay, so basically while guess is not a number, so when guess is not 42, we take the raw guess from the read line, which in this case will crash, so let's say it's 41. If raw guess is nothing, then continue. So basically go back and ask again. Then we convert that string.parseInt raw guess. Okay, so that's our string utilities where we can parse that string into integer. And if guess is 1001, nope. And we stop it, just quit. If it's large, it's too high. If it's not, too low. If it's good, then yeah, okay, that's simple. So we have simple while loop where we can completely exit out of it, or we can continue on to just skip. Okay, that's simple. We'll just put 42 here and we'll instantly get IHA. Okay. Iteration. So we can iterate with a for loop. So I an element. Okay, so we can take a array, take an array of 3 strings and iterate over them with an index. And basically elements. So yes is at index something. Okay, so if we run it, we should see it right under yeehaw. Mismatch is but a string. Oh, my bad. Okay, yeehaw. Yes is at index 0. No is at index 1, maybe so is at index 2. Alright. That was simple. And for KV and items, and we give it sequence of tuples. Okay, so we have tuple, person, you, and power, and me, and power. So we basically have a sequence of those. That's why we have that at symbol, and square brackets is the sequence of 2 tuples. And I guess you can, there's items, it basically returns pairs of key and value. So this is 0 and this is 1. So this should echo 1 by 1. V will be, value will be 100. Yes, down here we have 100 and 900. Yep, that's it. So basically return those tuples as K and V, because K is at index 0 of person and the other one the other. Okay, that makes sense. You can iterate over those. And then we have string multi-line row string. We saw that before. And looks like you can just start from next line to have everything formatted nicely. All right. And you are not supposed to have something like this. I guess there's no indentation here. Yeah, something like that probably wouldn't go through. It will probably return space and something. And then for each line, and split lines, so we split that string into lines. For each line, we just print it out. So we have an example, string to play with. So if I'll indent, looks like indents with spaces, even though this would be, let's call it Python-like. If we run it, we should see the result too. Yeah, they got indented. And it looks like it added an extra line after that. That was empty. Just those 2 spaces. Yeah, 1 and 2. Okay. So if we get back here, it'll be back to normal. Alright, makes sense to print those lines. So then for IC in my index and letter. Or for JN, or just letters. Okay, so this case we iterate over each letter in the string. We can check if it divides. So basically we're checking if that index is divisible by 2. If it is, we just skip it. So we print every second letter. And so basically if that we skip, we don't need to make a new indentation or anything. We just, if it's one word, I guess we can just do bam, that's the compact if form. Then we have else if the character is the capital X, we absolutely stop the whole thing. And if not, we just print it. So we should have the A skipped and printed. Space skipped, this printed. And we just did all that. So if we would do, for example, capital X, that little X wouldn't be printed anymore. It would just stop after that. And yes, it's printed N, and then angle bracket, and nothing else because it skipped the E, and then X countered, and it just broke it. Cool. Okay, we're getting to finally good stuff. Procedures. We define type a answer to be an enum, either yes or no. So we can define a procedure, so I presume it's just like function anywhere else. I believe, yeah, I started learning programming like then with, what is it, Object Pascal or like Delphi Pascal. And there was distinction between procedures and functions. Maybe this is the same here. So we have a procedure that's named ask, and we give it a question, which is a string, and it should return an answer, which is either yes or no. So we basically say our question and add yes or no. And then we're just waiting for an answer. So we read the line. If it's yes, any of those, it'll return yes. If any of those, will no. And if not, it will basically start over and wait for, say please be clear and wait forever. So you actually can't escape it. Okay, so we have simple procedure that will return either yes or no. And then we have add sugar, another procedure that takes an integer and looks like it's a default. Default amount is 2 and returns nothing. There's nothing there. It's interesting that those procedures, they end with equals and then you have your contents. Okay, I like it. That equals is funny. So here we assert that amount is this and that. Crazy sugar. If amount is larger than 0, okay, and amount is less than 9,000, we just call it crazy sugar. For and 1 to amount, echo sugar. Okay, so this basically should always say, unless of course it's over 9,000 or less than 0, it will say crazy sugar, and then basically print it out however many times are left. By default 2, or you would say 30, it will show more. So would you like sugar in your tea? No, if you say yes, so we call that procedure, it should return the answer so we can case over it, switch over it. So if it's yes, we do add sugar 3, and that should return crazy sugar, sugar, sugar. And if it's no, I'll do take a little and we add sugar just 2. So we crazy sugar, sugar. Okay. No need for else here, only yes and no are possible. Okay, so it looks like compiler is checking if there are any skipped cases. Okay, that's good. So let's try it. We don't have the read line available. So let's assume that it's always yes for now. And it should execute this. T prints sugar 1 to 3. Okay, maybe we'll show crazy sugar if it's anything else. Okay, so if we'll say it's -3, run it, it will just break, right? We have that. I guess this is just a note for us. Okay, alrighty. So we just have that. If we'll do 300 or 30, it will just go nuts. Okay, makes sense. So then we have FFI. Because nym compiles to C, FFI is easy. Oh, I presume that's when we have compatibility with C languages. I forgot what was FFI, like foreign function interface or something like that. But it looks like we have a procedure, the string compare, and we give it to C string. So that's interesting. And we return cint. So I guess that's the compatibility types between string and C version of the string, and we have C version of int. And that is interesting. Import C as string compare and node CL. Okay, I don't care about that right now. So that was the first learn nym in 5 minutes. I personally really liked it. That was really simple. So additionally, nym separates itself from its peers with metaprogramming, performance, and compile time features. And you can read more. Okay, that was nice and short.